Good morning. This is class 6 on the module 3 microcontrollers. Today we will discuss about external memory. So we know that any system is not limited by the amount of internal RAM and ROM. That is, merely internal RAM and ROM is not sufficient for memory storage. So two separate external memory spaces are there in the case of 8051 microcontroller, and they are made available by the already discussed 16-bit program counter PC and the DPTR, that is data pointer, and by different control pins for enabling external ROM and RAM chips. Now there are several reasons for adding external memory, especially program memory, when you are using 8051 microcontroller. Okay, when the project is in the prototype stage, then the expense, both in the case of time and money, actually have masked this ROM made for each program very prohibitive. So in order to overcome this problem, manufacturers make available an EEPROM version, that is erasable programmable read-only memory version, which is 8751, a 4K on-chip EEPROM. This is actually programmable and it can be erased as needed by the programmer. Okay, so the resulting circuit board will be exactly identical to that of 8051, whereas the only drawback of this EEPROM version, that is 8751, non-standard 40 pin part, and there will be only 4096 bytes of program code available. That is, program code available will be less. So 8751 solution works out well only if the program fit into 4K bytes. But we know that most of the programs are written in high level language and it actually exceeds 4K bytes. So definitely an external program memory is needed. So another version has been developed, that is ROMless 8031. Here EA bar pin, that is enable access pin, is grounded, and all the program code that is contained in it will be used as an external EEPROM of size 64K bytes. However, this can be programmed using the standard EEPROM programmers. External RAM is made up of 64K bytes and it can also be added to any chip in the 8051 family. There is no need of studying this diagram. This has been shown just for your reference. This is how an 8031 is connected to EEPROM. The connection between 16 bytes of EEPROM and 8K bytes of static RAM. How this 8031 is interfaced to this EEPROM and static RAM. So here 8051 access external RAM whenever certain program instructions are executed. External ROM is accessed when the external access pin, that is EA bar pin, is connected to ground. Okay, and then 8051 can use internal and external ROM automatically. This figure shows the timing associated with the external memory access cycle. Here you can see external memory addressing, reading ROM using PSEN, then accessing RAM using RD bar and WR bar. This is also given just for your reference, no need of studying that. This one you can go through, that is how all these actions are performed. That is during or when you are accessing a memory cycle, port 0 is time multiplexed, which means that first it provides lower byte of 16-bit memory address and it will act as bidirectional data bus to write or read a byte from memory or byte of memory data. Now port 2 provides high byte of memory address during the entire memory read-write cycle. The lower address byte from port 0 has to be latched into an external register to save the byte. Now this address byte saved is then accomplished using the ALE clock pulse, that is address latch enable clock pulse. Now port 0 pins will now become free to be used as a data bus. Now if memory access is for a byte of program code in the row, that is if memory access is for ROM, then PSEN bar, that is program store enable pin, will go low just to enable the ROM to place a byte of program code on the data bus. Now what happens if RAM byte is accessed? This is when ROM byte is accessed. Then now what happens when RAM byte is accessed? When RAM byte is accessed, WR bar and RD bar pins will go low. That is either WR bar or RD bar pin will go low, and this will enable the data to flow between RAM and the data bus. So when ROM byte is if the access is code on the data bus. Now when a RAM byte is accessed, the pins WR bar or RD bar will go low, and this will enable the data to flow between RAM and the data bus. Now we can expand the ROM to 64K by using another type of EEPROM, that is 27512. Now at this time the largest static RAMs available are 32K in size, and RAM can be expanded even up to 64K by using 32K RAMs that are connected together using the address bus A14 of port 2. Then you must note that WR bar and RD bar signals are actually alternate uses for port 3 pins, that is 16 and 17. Also, port 0 is used for lower address byte and data, whereas port 2 is used for upper address bits. Now, the use of external memory consumes many of the port pins, leaving only port 1 and parts of port 3 for general input output. That is, only a port 1 and some parts of port 3 will be used for general input output operations. So this external memory and all, the lessons on external memory and all are of least importance, so you can just refer through this class. Okay, but the probable essay question will be 8051 pins, ports and circuit that we have studied in the earlier classes. So external memory and all you can just go through. Okay, thank you.